This video will be about using a do loop in Mathematica. Let's suppose we have this polynomial and we want to find all three roots using the find roots command. Then we're going to give this initial value and repeat the same command 3 times with its 3 different initial values. So we can, whenever you have to repeat the same thing and several times, you can use this do loop. So for example, if I'm looking at this root here, it's going to be negative 1.5. This is roughly negative 0.2 something, and this is like 1.8. So we're going to repeat this find roots command with these 3 different initial values. So I recorded here negative 1.5 and negative 0.3 and 1.8. We'll repeat find roots command, and every time when we find the solution using the find roots command, we're going to store those results in here. Remember, those results are in the substitution form. This is how the do loop commands works. It starts with the do and the bracket, and this is the part that where you put down the things to do. For example, first line goes here, so let me just use this like a first line, and by typing enter, and then second line goes there. And these are supposed to be actual command, and I'm going to put the third line. It's about that. And if that's the last thing, and then you type comma, and then do loop has its index. So if we're repeating this one for the 3 times, it's going to be k. That's the index, and 1 to 3, and end the do loop. So by doing that, and the Mathematica will repeat this exactly 3 times, changing each time the k value to 1 through 3. So first value is 1, second value 2, third value 3. It'll repeat these 3 lines 3 times. So here we start with an empty set. It's a list. Then we're going to repeat the 3 tasks. First one is that we're going to pick the first initial value. So that's the list, and this double bracket picks up the elements from the list. So when k equals 1, that's the first value, this guest list bracket 1 will pick up this first value, negative 1.5, and store it as a temporary. That's the name of the variable I'm going to use. You can use a simpler one. In the next line, we use that temporary value, and to find the root, the formula 6 is the equation that is defined earlier, and set equal to 0, and find a root that is closer to this temp value, which is assigned here. And we use the same variable again, because that's keeping that temp here is not important. So I record this solution from this find root, which is in the substitution form here again, temp. And then this is the list, the solve find root, and then we add, kind of append that solution to that list as an element. Then you have to use this command append. And then at this stage, this sol fr will have 1 element in there in the substitution form. And you go back here and repeat this procedure again, with this time k value equals 2. So when k equals 2, this picks up the second element in the list, which is negative 0.3, and repeat exactly the same procedure, and then append that solution to this list, sol fr. Then after it repeated 3 times, it's going to exit the loop, and if you now return this sol fr, it's going to show all the 3 results, all the 3 solutions in the substitution form. Then they actually look like this. So by doing that, we repeated 3 times and got these results.